Okay, so now let's talk about the planet Venus. So let's first go over some general characteristics of Venus and then try to explain how they got there. So first, the size of Venus is roughly the same as the size of the Earth. So that means that on the inside of Venus, it should be just as hot as it is on the inside of the Earth. Okay, rotation rate. So it takes Venus 116 Earth days to make one complete revolution. And it also rotates backwards. So we think that that was due to a collision. So that Venus got hit hard enough that either it flipped it upside down, so now it rotates backwards, or it could have been a side hit on the planet and then it reversed the rotation. One way or another, we think it has something to do with the collision. All right, atmosphere. So Venus has a very, very thick atmosphere. It is 100 times the thickness of Earth's atmosphere. So the pressure on Venus is 100 times Earth's atmospheric pressure. If you were to set foot on the surface of Venus, you would be crushed instantly. So it is equivalent to the pressures that you would experience where the Titanic is located at the bottom of the Atlantic Ocean. Okay, what is the atmosphere composed of? Carbon dioxide, so CO2. Now you should know where CO2 comes from, so that's a clue as to why does it have such a very thick atmosphere. Okay, then temperatures. So temperatures on Venus are the hottest of anywhere in the solar system. It's so hot that if you took a block of lead and you put it on the surface of Venus, it would melt. So very, very hot. It has a runaway greenhouse effect. So we've talked about the greenhouse effect, and we said that if you have a planet and then it has an atmosphere that has carbon dioxide and water in it, then sunlight, when it comes in the form of ultraviolet light, when it hits the surface of the planet, the surface re-radiates it as infrared radiation, and then that infrared radiation is stopped by these clouds. And so that means that the planet gets warmer. And so the greenhouse effect is a good thing, but a runaway greenhouse effect is a bad thing. So because it has such a thick atmosphere composed of carbon dioxide, it traps all of this solar radiation that's coming in, and so it's so very, very hot on the surface. Okay, Venus does not have any oceans. So if there's any water, it would evaporate immediately due to intense heat. It does not have plate tectonics, which is kind of unusual because if it's as hot on the inside as the Earth, you would expect Venus to have plate tectonics, but it doesn't. So we're going to try to explain that. And then, the surface of Venus is very young. So it was resurfaced in lava roughly 500 million years ago. So we need to be able to explain that. It does have hot spots, so it doesn't have plate tectonics, but certain areas have molten material underneath the surface, and it's sending up blobs to the surface, and so that's what powers its volcanoes. And then it does not have a magnetic field. The top picture on the left shows you what Venus looks like from outer space. Very cloudy, and so originally when we looked at Venus through our telescopes, we thought that Venus was a tropical paradise because it would be closer to the sun than the Earth, which means it would be hotter, and so that would mean it would have more evaporation, more clouds, more rain, jungles, and so it would be very, very hot but livable on Venus. Well, it's not. So Venus does not have any liquid water on its surface. The picture, the top right picture, shows you what does the surface of Venus look like, and it's lava fields would be a good description of it. The lower picture shows you the topography of the surface of Venus, where the blue and purple areas represent low areas where it would have oceans if it had liquid water, and then the brown areas represent the continents. Okay, so now let's explain what went wrong on Venus. So we're going to assume that Venus originally had oceans. And so we know, so here is the surface of the planet, and then let's say that these are oceans, and we know that volcanoes produce CO2, which makes the atmosphere. But on Earth, what happens to that CO2 is it's absorbed by the oceans, and then it's turned into limestone. So the CO2 is captured, turned into calcium carbonate, and forms limestone. So roughly 90% of Earth's CO2 is in the form of limestone. Okay, it's captured. And then that limestone can be subducted underneath a continent, and then the CO2 can be released, and then it comes back out the volcano. So what happened with Venus? So with Venus, remember, it's closer to the sun. So it's distance that determined the fate for Venus. Since it was closer to the sun, it was initially hotter, and so these oceans eventually evaporated. They boiled away due to temperature. Okay, then without the oceans, that means there's no mechanism to store CO2. So the CO2 just kept accumulating in the atmosphere. The temperature kept getting hotter and hotter and hotter. So what happened to the plate tectonics? So on Earth, the lithospheric plates are wet in the oceans because the water from the oceans mixes with these rocks. So these are wet rocks here. And one of the things about wet rocks is that they melt easier. So that when subduction occurs, then that means that these plates, they can melt easier because they have water in them. On Venus, they're dry rocks. So there's no oceans. And so that means that they have a harder time melting, which means that the lithosphere on Venus is thicker than the lithosphere on Earth. And so the thicker the lithosphere, the harder it is to move around on the surface of the planet. So that's the reason why we don't think that Venus has plate tectonics. Okay, so that's some interesting things about Venus. So let's take a break, and when we come back, we will talk about Mars.